The next thing we'll look at is LU factorization of a matrix A. The idea being that we want to write the matrix A as a product of matrices. In particular is this L times U. So let's look at what the L times U is. We will let A be an m by n matrix, so it does not have to be square. And we want to find these matrices L and U, where A is equal to L times U. And then we have a couple of properties about these two matrices. L is going to be an m by m lower triangular matrix with 1s on the main diagonal. So lower triangular matrix means that everything above the main diagonal will be 0. U is going to be an m by n row echelon form of A, found only by using row replacement operations. So I'm only going to be able to multiply a row by a number and add it to another row. In order to do this, there's essentially going to be two steps. The first step is to reduce our matrix A to an echelon form U by a sequence of row replacement operations, where specifically a multiple of one row is added to a row below it. So that's the only row operation we're going to allow. We then want to place entries in our matrix L such that the same row operations that we used in step 1 will reduce L to the identity matrix. Here's my matrix A, and I want to row reduce this to get to U. We can only add a multiple of one row to a row below it, so we're not going to get 1s. Instead, we're only going to get 0s below our pivots. So my first step would be to get a 0 in this spot with a -4 in it. I'm going to do that with the operation 2 row 1 plus row 2. My first row will stay the way it is. 2 times 2 is 4, minus 4 is 0. 2 times 4 is 8, minus 5 is 3. 2 times -1 is -2, plus 3 is 1. 2 times 5 is 10, minus 8 is 2. And 2 times -2 is -4, plus 1 is -3. We now want to get a 0 in our next spot. And I can do this with negative row 1 plus row 3. -2 plus 2 is 0. -4 minus 5 is -9. -1 is 1, minus 4 is -3. -5 plus 1 is -4. -2 is plus 2, plus 8 is 10. Finally, we'll work on getting our last 0 in the first column. To do this, I'll do 3 row 1 plus row 4. 3 times 2 is 6, minus 6 is 0. 3 times 4 is 12, plus 0 is 12. 3 times -1 is -3, plus 7 is 4. 3 times 5 is 15, minus 3 is 12. 3 times -2 is -6, plus 1 is -5. We now have the first column the way we want it to. For the second column, once again, we need to only add a multiple of one row to rows below it. This time our first and second rows will stay the same. I need to get a 0 below this 3. And in order to do that, I'll do 3 row 2 plus row 3. So 3 times 3 is 9, minus 9 is 0. 3 times 1 is 3, minus 3 is 0. 3 times 5 is 15, minus 4 is 11. 3 times 2 is 6, minus 4 is 2. And 3 times -3 is -9, plus 10 is 1. So now we'll move on to the fourth row. For this, I'll do -4 row 2 plus row 4. And then have -12 plus 12 is 0. -4 times 1 is -4, plus 4 is 0. -4 times 2 is -8, plus 12 is 4. And -4 times -3 is 12, minus 5 is 7. And we're almost done. Our next pivot is going to be this 2, so we need to get a 0 below it. We need to turn this 4 into a 0. This time my first, second, and third rows are going to stay the same. I'm going to do -2 row 3 plus row 4. So the first 3 entries are 0 plus 0. -2 times 2 is -4 plus 4 is 0. And -2 times 1 is -2 plus 7 is 5. This matrix now is in row echelon form. So this matrix right here is my U that I wanted to find. So now I just need to determine what L is. For this matrix, since our original matrix had 4 rows and 5 columns, we know L is going to be a 4 by 4 matrix. It has to have the same number of rows as A, and it needs to be square. We also know it has 1s on the main diagonal, so I went ahead and wrote those. And it's lower triangular, meaning everything above the main diagonal is 0, so I went ahead and put those in. And like I said, the same row operations that we use need to be able to transfer L to the identity. So if I go back up, my first matrix multiplied by 2, -1, and 3. So to undo these, I would need to do -2, +1, and -3. And that's what I'm going to insert into my L. It's essentially just changing the signs of the operations I did. For my second column, if I go back up, my operations were multiplying by 3 and -4, so my entries are going to be -3 and 4. Finally, my last operation was -2, so my last entry will have a +2. So now I have my matrix L. Let's repeat this for a much smaller matrix. This time I'm going to do a 3 by 3. My first row will stay the way it is. And to get a 0 in the second row, I need to do -2 row 1 plus row 2. That'll give me -2 times 2 is -4 plus 4 is 0. -2 times -3 is 6 minus 6 is 0. And -2 times 7 is -14 plus 5 is -9. I then move down to my third row. That one, I can just add rows 1 and row 3. 2 minus 2 is 0. -3 plus 9 is 6. And 7 plus 1 is 8. At this point, we have a big problem. Our next step should be to switch the second and third rows. However, that's not an allowable operation when finding LU decomposition. So therefore, the LU decomposition of this matrix does not exist. So it is possible for this to just not exist.